Hi there! Today we're going to do a little geometry review so we can explore some special angle properties and more advanced situations. I'd like you to take a look at this short video on your basic angle review.
Between 0 and 90, an angle is acute. This angle's small and skinny and kinda cute. It looks like a V or the top of a Y, or the angles that you see eating pizza or pie.
Angles are measured in degrees, and here's how to remember them with ease.
See, when an angle measures 90, do we call it right? You can tell this angle just by sight. It looks like an L or the corner of a square. You're looking at them when you're walking up the stairs.
Angles are measured in degrees, and here's how to remember them with ease.
From 90 to 180, an angle is obtuse. This angle's kinda fat, it's got a big caboose. Like the hands on the clock when it's 1:45, or the antlers on the head of a full-grown moose.
Angles are measured in degrees, and here's how to remember them with ease.
To measure an angle's degrees with a protractor. Place the vertex at the hole in the center. Line up one ray at 0 on the protractor. Remember that the 0 can be on top or under. Count up to where the other ray points at the number. That will be the angle's measure.
Angles are measured in degrees, and here's how to remember them with ease.
Alright, so the four basic angle types are the right angle, the straight angle, the acute angle, and the obtuse angle. Just don't forget that you should be told if it is a right angle or a straight angle. Or you should be given the degrees, or in a right angle, you would want to see this little square that signifies it is actually a right angle. Sometimes when we look at it, our vision could tell us maybe it looks like it's 90 degrees, but it might really be 89.9 or even 90.1 degrees. So it could be slightly off. You want to be told or have that symbol of the square in the corner. Next, we're going to take a look at some other angles that should be reviewed, complementary and supplementary angles. Another short little video.
We speak student.
Complementary and supplementary angles, a la Schmuck. Claude the sad clown has been doing his best to make kids happy at the Smiling Circus. Unfortunately, he hasn't had much luck. A new funhouse is scheduled to be built at the Smiling Circus, and all the clowns, Boo Boo, Dimples, Twinkle Toes, and Dr. Gigglestein, thought it might cheer Claude if they allowed him to build it. Plus, that way he won't depress the rest of the visitors. While building one of the windows for the funhouse, Claude finds that the window needs a diagonal brace to support it. If the corner of the window is at a right angle and the brace is at a 50-degree angle from the bottom, how many degrees from the side is the brace? Alright, so let's think this through. First things first, let's label our angles. The corner of the window is a right angle, so let's indicate that with a box in the corner. It's also good to keep in mind that right angles are 90 degrees in measure. The only other angle we know is from the bottom to the brace, which is 50 degrees. We want to find the measure of the other angle. Since we don't know it yet, let's call it, x. How clever. To solve this, we can use the idea of complementary angles.
Oh, lovely. Oh, lovely. You look lovely. You look lovely. Oh, you do.
Or two angles whose measures add up to 90 degrees. Since x and the 50-degree angle add up to 90 degrees, we can find x by solving the equation x plus 50 equals 90. Subtracting 50 from both sides gives us a value of 40 degrees for x. Feeling a little less sad, Claude goes on to build the floor. He wants to make the door to the funhouse tilted so that it's at an angle of 65 degrees. How tilted must the door frame be in relation to the wall? Again, we should start by labeling our angles. We know that the angle of the door is 65 degrees, and we'll call the other one x, since we don't know it yet. Even though the door frame is tilted, the floor is still a straight angle. Since we know straight angles are 180 degrees in measure, the two angles here are supplementary angles, or two angles whose measures add up to 180 degrees. Since we know the two angles add up to 180 degrees, we can set the equation x plus 65 equals 180 and solve for x. So subtracting 65 from both sides gives us x equals 115 degrees as our answer. Claude has figured out all the angles in his funhouse, and building it has made him much happier. He still has the occasional relapse, but he's cut down his solving sessions to only about once a week. Poor Claude.
All right, so your complementary angles are the two angles that together equal 90 degrees. And your supplementary angles are your two angles together that equal 180 degrees. Hopefully you remember that from review. What I get a lot of time is, how do I know which one is 90 and which one is 180? I get confused. So here's a little mnemonic device that I tell my students. The C in complementary, if you were to take that, well, first of all, C comes before S in the alphabet. So here we have our C, here we have our S. So since C comes before S in the alphabet, 90 comes before 180 on the number line. So C before S and 90 before 180. That's one mnemonic device to remember. Another mnemonic device that I would use is I would say, well, you could take the C and you can turn it into a 90 degrees. Just continue around and add that in, turn it into a 9 and turn that into a 0 for 90 degrees. And for the S in supplementary, you can quickly and easily turn that into an 8 to remember 180 degrees. So two little mnemonic devices to help you tell the difference between complementary and supplementary angles if you get stuck or you get a little confused. It's all about the relationships. We studied in elementary school different special angle relationships that are formed when you have parallel lines, when you have perpendicular lines, intersecting lines. So we need to do a quick review of them as well. The first special angle relationship that we're going to talk about is when you have two intersecting lines and they cross, they form what we call vertical angles. And our vertical angles are going to be our angles that are across from one another, and they also have the same angle measure. So if angle A is 10 degrees, angle C would also be 10 degrees. They are across from one another. Another special angle relationship that we find when you have intersecting lines would be adjacent angles. And those are the angles that are next to each other or beside each other. They equal 180 degrees. So that's the relationship that's formed. Those are the two that you've studied in 6th grade, and we utilize those here again in 7th grade and on into 8th grade.
We speak student.
Parallel lines, transversals, and angles, a la Schmupp. There are some couples who are just destined to be together forever. Romeo and Juliet, Cinderella and Prince Charming, Paula Deen and Butter. But the greatest couple of them all has to be parallel lines. Parallel lines never touch, but they always stand by their partner. Now that's love. When a transversal cuts across two parallel lines, it forms 8 angles. If the measure of angle 1 is 110 degrees, what are the measures of the other 7 angles? First, we can see that angles 1 and 3 are vertical angles, and we know that vertical angles are always congruent. In other words, they have equal measurements. So angle 3 has a measure of 110 degrees too. It also helps to know that corresponding angles, or angles that are in the same position relative to the parallel lines and the transversal, are also congruent. In this case, the corresponding angle to angle 1 is angle 5. So angle 5 is also 110 degrees. Wait, so angles 3 and 5 are congruent too? Actually, yes. They're both on the interior between the two parallel lines and on alternate sides of the transversal. So we call them alternate interior angles. All alternate interior angles are congruent. And there's one more angle that's 110 degrees, and that's angle 7. So angle 1 and angle 7 are both on the exterior of the parallel lines and alternate sides of the transversal, and they're called alternate exterior angles. Alternate exterior angles are also congruent, and we can check that using vertical angles or corresponding angles. Yep, looks like 110 degrees to us. Those are all the odd angles, but what about the evens? We know that a straight angle, or a line, has 180 degrees. Since any even angle makes a linear pair with an odd angle, any even angle is supplementary to an odd angle. That means the even angles have a measure of 180 minus 110, or 70 degrees. And ta-da! You now have all your angles. So don't forget to include parallel lines when listing the world's great love stories. And as a bonus tip, don't ever try to get between Paula Deen and her butter.
So back to special angle relationships. So you learned in 6th grade about the vertical angles and the adjacent angles that are formed when you have intersecting lines. Today you got a sneak peek at the special angle relationships that exist when you have parallel lines. This year, you're just going to focus on finding those missing angle measures, not necessarily being able to use the terminology in your vocabulary to prove why. That's what you will do in the 8th grade. You will give the reasoning and you'll understand the connection. But I really wanted you to begin to see this today. So let's take a quick review at those angles that are formed, the special angles that are formed when you have two parallel lines that are cut by what we call a transversal. So let's start off with, just remember that parallel lines never intersect. They go on forever without touching. And that transversal is the line that cuts those two parallel lines. Now, I just happen to put mine at this angle. It could be straight up and down and be perpendicular to the parallel lines, or it could cut at another angle. The relationships are still going to remain. And for 7th and 8th grade purposes, our two lines will be parallel. They're usually parallel in the 7th and 8th grade, but they do not need to be parallel. So please keep that in mind as well. Corresponding angles are the angles that are formed when that transversal cuts. So this is one of the special relationships that you're going to see, the special angles. A and C are corresponding angles. They're in the same position, but they're on a different line. This is going to seem kind of weird, but what I did was I took a cut of angle 4, and I'm just going to show you how you could take what's really unique about transversals. You could take the top angle, take a picture, snapshot, cut it, and look, you can drag it down and it's the exact same angle. If I were to cut this in half and break it apart, you would see they're like twins. They're identical. Alternating interior angles. So another special relationship that is formed when you have two parallel lines that's cut by a transversal. Those are focused on the inside, the interior of your transversal, and you've got the inside and opposite side. So that's where the word alternating comes from. The E is on the left, the D is on the right. They're alternating from left to right, but they're also on the inside, the interior of the parallel lines. We have our alternating exterior. It's the opposite. Instead of being on the inside, it's going to be on the outside of the parallel lines, and it's alternating as well. One is on the left, one is on the right. A unique relationship that exists between alternating interior and alternating exterior is the angle measures are equal. So that's unique to this relationship as well. The last thing I would like you to do before you come to class is I want you to try your IXL practice. These are the 3 that I would like you to explore, W2, W13, and W14. Remember, your goal is always to try to achieve an 80% mastery in each of these links. If you click on it, it'll take you right to your IXL page. If you're not signed in, don't forget, you can always get 10 free ones a day. And there you go. Thanks for joining me today.